So it should say 2.5 day 2 notes, geometric proofs at the top. Okay. So starting this off, starting off with geometric proofs, we've done algebraic proofs, right? And we've talked about all the properties that we need and definitions in order to do a geometric proof. Now we're going to kind of step our way through our first couple of proofs together. And most of the time, your proofs, just like the ones that we did with algebraic proofs, will be in the fill-in-the-blank format or multiple choice. Morning. Thanks. You just got started with notes. Okay. And in general, the proof process is a lot like a puzzle. There's things that you do first, there's things that you do next, and there's things that you do last. There's certain things you can do to kind of build yourself a framework that will make your life easier in the long run. So in any proof you're doing, step one is to state the given information. So usually you'll have a part of the proof that's the given, and then you'll have something you're trying to prove. And so when you state the given information, if you think of this in terms of a puzzle, so bear with me, I know not everyone does puzzles anymore, but hopefully we've all done a puzzle at some point in our lives. Does anyone know what you usually do first on a puzzle? Make the corners, right? Find all the corners. Stating the given information is kind of like finding the corners on a puzzle. It's a thing you do first. It's a guaranteed first step. So if we were going to do that for this proof, if we have statements over here and reasons over here, our first step would be to state the given information. So in this case, our given is that R is the midpoint of QS. And our reason, our very first reason, is always just given. Okay. Now, you don't always know exactly how many steps your proof is going to have. Most of the time, you guys will know. Most of the time, we'll give you kind of the fill-in-the-blank format where you'll know exactly how many steps the thing is going to have. So for this one, we're going to go with 3 steps. If you weren't sure, this next step, you could just kind of write somewhere near the bottom so that you know where you're headed. For the last statement, you're always stating what you were trying to prove. So the very end is always going to be this thing that you were trying to prove. So if we're going with kind of the puzzle mindset and we've done the corners, what do you do next on a puzzle? Yeah. Yeah, the edges, right? So this is kind of the border. So we're figuring out where we're going to go, where we're stopping, basically. So this is like the edges when we put in on our last statement the thing that we were trying to prove. So that's going to be that QR is congruent to RS. And we might not know the reason for it yet, but we know that that's where we're headed. Okay. And so then once we've got the given and we've got our last step in there, then we're building an argument for this based on the other true facts that we know, the postulates, the properties, the not properties, it should say properties. There should be a P there. And we do that last just like the middle of a puzzle. So now we're looking at our what we've been given, and we're trying to go from this to what we're trying to prove. And we were told that R is the midpoint of QS. So what does that tell me up here in my picture? If R is the midpoint, what do I know about these two pieces? Yeah, Olivia.
That QR is equal to RS.
Yeah, QR is equal to RS, and that's actually going to be step 2. And my reason for that is just the definition of a midpoint. Just like we had yesterday on our homework, when we saw a situation like this, our reason for it was definition of midpoint. Okay. And now that we have all of our statements going from step 2 to step 3, we just have to figure out what lets me go from something being equal to those same two things being congruent. Look back at your list of properties and things. What do you got? Definition of congruent. Yeah, so anytime you're going from equal to congruent with those same two things on either side, definition of congruent. And then you're done. And that's it. So that's a geometric proof. And that's the whole process.
Why?
What?
Why?
Why?
Wow. Wow.
Wow. All right. Yeah. So, I mean, it's not that awful, right?
Wow.
Go ahead, turn the page. We're going to do some more of these together. All right. Some more in like the fill in the blank style. So I know this page has a lot of blank space on it. The middle is what we're looking for here. It's mostly because I deleted a bunch of other stuff on the page that didn't seem as useful. Okay, so here we go. Next one we're doing together right here. We've got given AC is equal to BD. Prove AB is equal to CD. So what was step 1? Right, AC equals BD. We always fill in what we've been given first. And then we check, okay, the thing that we're trying to prove, it's already actually filled in for us down here. So we're good on that front. Now, let's go label the drawing real quick with what we know. We know AC is equal to BD. So that's AC is this part right here. BD is this part right here. So we know this is true. We know these two segments are equal to each other in length. And what we're trying to get to is that AB is equal to CD. So we're trying to figure out how we can show that AB, just this part right here, is equal to CD, just this part right here. Okay, so now we have our diagram labeled. And if we think about it, it kind of makes sense, right? Because these two things, if this part is the same length as this part, and they share this middle section, it makes sense that the two ends would have to be equal as well. So now we just have to show that. Okay, so here we go. The next part says AB plus BC is equal to AC, and BC plus CD is equal to BD. All right, so AB plus BC equals AC. BC plus CD is equal to the whole thing, BD. Look back at your list of properties. What does this look like? Tell someone next to you, what does this look like?
I don't have the property.
Yeah, I know.
What'd you get, Isabella?
I got a segment addition.
Segment addition. That's what I got too. And if that's what you guys got, you are correct. All right. Segment addition postulate. Yeah, both of these things are the same postulate. It's segment addition. That's why they lumped them together into one step. Sometimes you'll see that where two things are lumped into one step, and it means just the same reason for both of those things. Okay. The next part wants us to use the substitution property. Now notice, AC is equal to BD. We have that already. And this is another way to represent AC. This is another way to represent BD. So if that's the case, I can take this and plug it in for AC. I can take this and plug it in for BD. So then we get AB plus BC is equal to BC plus CD. So that's where we're going to see substitution used. I know we haven't seen it used a whole lot yet when we were doing algebraic proofs and stuff like that. That's where we're going to see substitution. We're going to start seeing that more and more. All right. So from here to here, algebraically, or this is sort of a useless step, but we'll go with it. BC is equal to BC. What does that property look like? That's one of our old ones, Shauna. Reflexive property. All right. So what I'm really interested in here, though, is with this equation, what can I do to both sides to get AB is equal to CD? Anyone see it? So we're looking for what happens to get from step 3 to step 5 on both sides of the equation. You think you see it, Olivia? That's it. So if you subtract BC from both sides, I'm going to grab a different color here to show this. If I go minus BC, because really these are numbers. It's the length of BC, right? If I subtract that from both sides, it goes away on both sides, and we are left with AB is equal to CD.
Why didn't you just cross out the middle?
Right. That's what makes, that's why I don't love this step right here, because it seems a little bit useless, but because really you could go from 3 to 5, because clearly BC is equal to itself.
Yeah, so why didn't we just cross out the same? When we're doing stuff like this, can't we do that? Can we just cross out the middle and just be like AB equals CD?
You can cross it out if you know that what crossing out is doing is subtracting from both sides, because that's where when we get to step 5, we have to say subtraction property. Yeah, so if you know that it's subtraction that you're doing, then yeah, sure, you can cross it off. But only if you know that that's what you're doing. Question.
On the test, do we have to like step 4?
On the test, it's not going to include something like step 4 where it's kind of a useless step. And on the test, it's going to be the fill in the blank format. So it'll already include all of this, the number of steps and what exactly the steps are and stuff like that. You're just going to be filling in parts of it. Kind of like this, except I don't usually include useless steps. But anyway, that was a fun trip. Let's flip to the next page. Okay. We're going to do another one together. This one is similar to the other one that we just did, but it's a little different. Let's do it. So this one we have given, and we have 2 things in our given this time. So sometimes you'll have more than one thing in your given, and so given might be more than one reason in your proof, which is kind of fun. We have X is the midpoint of WY. And that's our first statement right here. That should be given. And then we also have XY is equal to YZ. So let's label that in our picture. XY is equal to YZ. And sometimes your givens won't always be at the beginning. Sometimes you'll see them sprinkled throughout the proof. So like we found this one down here, XY is equal to YZ. That one's also going to be given. So that's 2 freebie reasons, right? What goes at the end of our proof? What's our last statement going to be?
WX equals YZ.
Yeah, WX equals YZ. That's the thing we're trying to prove. So we're going through, we're filling things in. Now we've, once we filled in all of the given information and the thing we're trying to prove, we only have 3 things left to stick in there. So that makes our lives easier. Notice if X is the midpoint of WY, X is the midpoint of this. So that also tells me then that WX is equal to XY. So now we have all three of these things being the same length because of either something we were given here with telling us directly that they were equal, or something being the midpoint, which tells us that these are equal. So that's cool. All right. And it just so happens that the next step is that WX is congruent to XY. How do I know that? What's that? The congruent thing? Almost. If I know that these are congruent,
Oh, because of the lines. The lines in the thing don't run that split. Is that what you're talking about?
like the ones we drew in the picture,
Yeah.
it has something to do with what the ones that we drew in the picture. It also has something to do with our given here. What do you think, Tavia?
Because if X is the middle of like that whole line, then both sides are gonna
Yeah, if X is the middle, then these two are congruent. So that means it's definition of midpoint here for this one. Then, like you were saying, when we went from congruent to equal, that's where we can use the congruent one, the definition of congruent. Okay. And then we have WX is equal to XY. XY is equal to YZ. So WX is equal to YZ. We have a property from this for this. Remember those reflexive, symmetric, transitive properties? Which one does that look like? What do you
The one
think?
that switched.
Yeah, transitive. So if we write it out side to side, we can recognize it a little better. WX equals XY. XY equals YZ. So WX equals YZ. There's our middleman, the one that's the same. If we cut that out, we get WX equals YZ. That's how we know that this one is transitive. Okay. So these the last couple of proofs that we've done, to some extent are a little bit longer than the ones that you'll see on your homework tonight. The ones we're doing on our homework tonight are going to be short, sweet, getting us used to this proof process. So once you have this, go ahead and turn the page.
This ain't true.
And we're going to try some of these with a little bit less direction from me. Okay. So looking at the first one, you have your given, you have what you're trying to prove. You only have to fill in one reason right here. Look at it, label your drawing, and then try to figure out what this reason might be. Take a moment on your own. Try to work out the first reason. If you see a vocab word in there like bisector or midpoint or vertical angles, those tend to be involved in your proof. Look at your list of reasons and see what does that picture look like. Yes. I think you did.
I just always
Second
ask,
guessing
and
yourself.
yeah, I overthink it.
Yeah, don't overthink this one. Don't overthink it. What do you think it is? Nope, it's from your packet. What do you think? Definition of. Talk to the people around you. Compare your answer for this one. What do you think it is?
I don't have the definition.
I heard a lot of definition of midpoint. If that's what you picked, you are correct. Definition of midpoint here. All right. Let's see. 2 and 3 will be part of your homework tonight. We're going to skip down to number 4. Go ahead and try number 4 now. You've got 2 things to fill in. See if you can fill in both of those. So 2 and 3 are going to be part of your homework that you'll do on your own. Try number 4 now. And we'll check that one together. So what goes up there? Always. Put that on the last one. We're doing both of these.
I know this one, I just wanted to use.
So how do you get that?
Maybe not.
Angle A is congruent to angle C. And then measure angle A.
Does that include the
So we didn't switch sides. Because that would be like, that would have to be like. How do you go from here?
That was loud.
How do you go from Talk to the people around you. Compare real quick. Help each other out. That's good. This one's not quite. How do you go from here to there? That's the difference.
I got that.
Really?
I did.
How do you say different check?
I don't understand it.
Part of it's
Oh, that's the oh, yeah.
How would you know? Like, cause she said that the time was there first and then so how would you know without me doing You don't know. That's what I'm trying to ask.
All right, let's talk about number 4. The first thing you do, the very first thing, write in what you're trying to prove on the last step. All right, and then the only other thing we need to fill in is the reason for step 3. Now, really, we're looking for how can we go from step 2 to step 3 from things. So we have angle A is congruent to angle C in step 2. To the measure of angle A is equal to the measure of angle C in step 3. How do I do that? Olivia? Definition of congruent. Anytime you go from something being congruent to those same things being equal or vice versa, that's definition of congruent. Okay. Next one. Go ahead and try number 5. Try number 5. You all know what goes in the last step, right? How's it going back here? Wonderful. We'll go number 5.
Oh, okay.
You're close. This part is right, but what is equal to? It's not quite. We're close now.
So that means.
You're close. The addition part isn't that, but no, you can call them total.
Oh.
Yes. Yeah. That's good. That's very close, except it's not 180. We're doing angle addition. What's it equal to? Alright, yes, you have it, except you don't have to call it 1A and not B2 or anything like that. Just call it angle 1A.
I put 180. I put AB.
Yes, you can call it ABC.
What does that say? What is it? No.
You're close. You don't have to add angle.
Never mind, I know what I'm trying to say.
Instead of 180.
You're trying to say, I didn't.
And it's like,
Yeah, it gets 180.
Oh my god.
what is it?
What is it? So we've got to, like, we got to struggle a little bit.
How do you think?
Lord your knowledge over somebody. No, we got
Were you just-
Yeah.
How did I get her approval when you did it?
That's because.
No, it's.
All right, sounds like we've discussed these together a bit. Let's talk about these ones as a class. The last step looked like everybody got. The third step we got a little hung up on. Measure of angle 1 plus measure of angle 2 equals 180 is the last step. We know that because that's what we're trying to prove. The third step, though, we need to use angle addition postulate. That's that thing that says that you can add 2 adjacent angles and it equals the whole angle, right?
Oh.
So angle 1 plus angle 2, I saw a lot of angle 1 plus angle 2's in there. If I add angles 1 and 2, what other angle is it equal to? Yeah. ABC.
Oh my god.
Because then angle ABC is 180, so they swap out angle ABC for 180 in the last step, and that's why it's substitution for the last step. Okay. Question. Some people draw their angle symbols like this with the little line thing going through it. I don't. Some fonts do it. No, you don't have to. You can just draw the regular angle symbol.
What is that little line? It doesn't mean anything.
It doesn't really mean anything. It just means it's the angle symbol for this font.
Oh, so you don't have to.
Yeah, it's just a font difference. You don't have to do that. Good question. Because you never know when it might be something different. All right, so tonight's homework. You have 2 and 3 from up top. On number 6, there's a typo. Look at number 6 for a moment. It's something actually that got moved to the next page. It should say prove that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 90. That's what it should say at the bottom, but it got cut off. So sorry about that. So from this page, 2, 3, and 6 are part of your homework. And then turn the page. And see it got moved to the top of 7 here. So cross that off. That was supposed to be at the bottom of the page. And then let's see, we'll do 7, 8, and 9 here. Try your best on them. And then we'll talk about them tomorrow. And, if you get confused at steps, I'll probably post a video of some kind going over at least one of them. So you have time to work on it now. Have fun. Get started.